Welcome to the DIY Honda Garage channel. DTC P2126 indicates a problem with the Accelerator Pedal Position APP Sensor B, specifically the TP Sensor E. This issue arises when the sensor readings fall outside the expected voltage range, affecting the vehicle's ability to accurately detect the accelerator position. The APP sensor is crucial for the Engine Control Module, ECM, as it translates the driver's throttle input into a corresponding signal for the engine management system. Its location is typically found on the accelerator pedal assembly, and it can significantly impact engine performance if malfunctioning. Proper diagnosis involves checking the sensor's voltage output when the ignition is in the on position to ensure it is functioning correctly. The following slides will delve into the symptoms, possible causes, and detailed troubleshooting steps required to resolve this error code. DTC P2126 is triggered when APP sensor B, also known as TP sensor E, is out of its normal operating range. This sensor plays a vital role in relaying the position of the accelerator pedal to the Engine Control Module, ECM, influencing throttle response and fuel management. It is typically mounted directly on the accelerator pedal assembly and is designed to measure the pedal's position through varying voltage outputs. When the voltage signals deviate from expected levels, specifically when it measures 0.23 volts or less, or 2.65 volts or more, the system registers a fault. Ensuring the APP sensor's proper function is crucial for maintaining smooth vehicle operation and performance. Neglecting this issue can lead to inconsistent throttle response, reduced power output, and potential safety concerns when accelerating. The diagnostic trouble code P2126 can arise from several possible causes. Primarily, a malfunction in the APP sensor itself can yield erroneous readings, leading to the vehicle's inability to properly gauge throttle input. Wiring issues are another common cause, where damage or wear to the wires leading to the sensor can disrupt the signal transmission, resulting in voltage anomalies. Additionally, poor connections at either the sensor or the powertrain control module, PCM, can lead to intermittent faults. It is important to inspect the connections for corrosion or looseness, as these can manifest as sporadic failures. Ultimately, understanding these potential issues provides a clearer pathway for effective troubleshooting and repair, ensuring the vehicle operates safely and reliably. Symptoms of DTC P2126 may manifest as an unresponsive accelerator pedal, where the vehicle fails to accelerate despite the pedal being pressed. Drivers could also experience reduced engine performance or hesitation, particularly when attempting to accelerate quickly. Additionally, the check engine light will likely illuminate, alerting the driver to an existing fault within the vehicle's electronic systems. If these symptoms occur, it is imperative to perform diagnostics promptly to prevent possible safety hazards and further mechanical damage. Vehicle performance issues following the DTC are significant, as they can hinder the driver's ability to control speed safely, leading to potential accidents or breakdowns if left unaddressed. In the first troubleshooting step for DTC P2126, begin by turning the vehicle to the on mode without starting the engine. This action allows access to the vehicle's electronic diagnostic systems via the Honda Diagnostic System, HDS. Next, check the voltage output for APP sensor B. The measured voltage should be 0.23 volts or less. If it matches this threshold, it confirms that the failure condition persists, and you should proceed to step 3. However, if it does not meet this threshold, move on to step 2 to explore further. Proper voltage reads are critical. If the voltage is out of specified limits, it indicates an issue with the APP sensor or wiring, prompting further diagnostic evaluation. Proceeding to troubleshooting step 2, Again, check the voltage of APP sensor B while the vehicle is in the on mode. This time, verify that the voltage measures at least 2.65 volts or higher. If this condition is met, it indicates that the failure has indeed reappeared, directing you to Step 8 for more extensive diagnosis. Conversely, if the voltage does not reach the threshold, it suggests there may be an intermittent failure. In this scenario, inspect the connections carefully, looking for loose terminals or poor connectivity at both the APP sensor and the PCM. Such faults can cause erratic behavior in voltage readings, complicating diagnostics, but are often easily rectified with a thorough visual inspection and reconnection. For troubleshooting Step 3, start by turning the vehicle to the off, lock mode. Once deactivated, disconnect the 6P connector from the APP sensor. This disconnection is crucial to isolate the sensor and prepare for accurate voltage checks. Then, turn the vehicle back to the on mode while keeping the APP sensor disconnected. Measure the voltage between designated test points at the connector. If approximately 5.0 volts is present at the terminals, it indicates that the voltage is reaching the sensor correctly from the PCM, and you should continue to Step 4. However, if the voltage is not about 5.0 volts, the PCM may not be providing the correct signal, and you should proceed to Step 7 to investigate further potential causes. In troubleshooting Step 4, ensure the vehicle is turned off, lock, and proceed to jump the SCS line using the HDS, waiting for more than 1 minute to stabilize the system. Next, disconnect the PCM connector A, 50P, to isolate the PCM from the circuits. A continuity test will then verify if there is a short in the APS2 wire. Using a multimeter, check for continuity between designated test points where the APP sensor connector meets the body ground. If continuity is present, this indicates a short is found in the APS2 wire between the PCM and the APP sensor, necessitating repair of the wiring. Otherwise, if continuity is absent, it points to the absence of shorts in the wire and directing intentions to Step 5 for further checks. For troubleshooting Step 5, reconnect the system by connecting terminals A and B with a jumper wire between the APP sensor connector and body ground. This will allow for continuity checks in a controlled environment. Once set up, verify continuity between specified test points while ensuring the vehicle remains in the off-lock mode. If continuity is confirmed, the APS2 wire is functioning properly, indicating a need to progress to Step 6 for additional diagnostics or checks. Conversely, if continuity fails, an open circuit in the APS2 wire between the APP sensor and the PCM is present and must be repaired to restore functionality. In troubleshooting Step 6, remove any jumper wire used for previous checks and reconnect the PCM connector A, 50P. Following reconnection, set up another jumper wire between the relevant terminals on the APP sensor connector, while turning the vehicle to the on mode to prepare for voltage measurement. The next step involves checking the voltage for APP sensor B once again. If the value reads 0.23 volts or less, it confirms the APP sensor is indeed faulty, and further actions should include consulting authorized service documentation for additional guidance or replacing the PCM if needed. If the sensor voltage is not within this range, the most likely issue will indicate a failed accelerator pedal module needing replacement. During troubleshooting Step 7, start again by turning the vehicle to the off-lock mode. Jump the SCS line with the HDS while waiting a minute for the system to react. Disconnect the PCM connector A, 50P, and use a jumper wire to connect the APP sensor connector terminal to body ground. This setup allows you to conduct continuity tests between specified points. If continuity checks out, it confirms the VCC5 wire is intact with no issues, suggesting to consult any authorized service information for further steps or consider substituting the PCM. However, if continuity fails, you will have to address an open circuit in the VCC5 wire leading to the APP sensor, necessitating repair work to restore proper signaling. For troubleshooting Step 8, prepare the vehicle by turning it off, lock mode, followed by reconnecting the APP sensor 6P connector. Once reconnected, turn the vehicle back to the on mode. The next step involves measuring the voltage output from the APP sensor connector to observe if it registers around 5.0 volts. This measurement verifies that the sensor receives the correct voltage supply. If the voltage meets this requirement, it confirms that the issue resides within the accelerator pedal module, warning you to replace it. If voltage does not meet the necessary level, proceed to Step 9 for further checks with alternative systems related to the APP sensor functionality. In the final troubleshooting step, turn the vehicle off, lock, and jump the SCS line for stabilization. Following this, disconnect the PCM connector A50P again. Using a jumper wire, connect the appropriate terminal of the APP sensor connector to body ground, which will allow you to check the continuity between the designated test points. This check is essential to ensure the SG5 wire is intact and sending signals correctly. If continuity is confirmed, you are to review any service documentation for further instructions or replace the PCM if necessary. However, if continuity testing fails, this indicates an open circuit in the SG5 wire, requiring repairs to restore proper electrical pathways between the module and sensor. After addressing all potential issues related to DTC P2126, it is vital to perform final checks to verify the repairs completed successfully. Begin by reconnecting all connectors securely, ensuring a proper connection to both the APP sensor and PCM. With everything in place, clear any stored diagnostic trouble codes, DTCs, from the vehicle's memory using the Honda Diagnostic System. Subsequently, undertake a road test to thoroughly assess the vehicle's performance, confirming all components are functioning without triggering any alarms. Monitoring the performance in varied driving conditions is crucial, focusing on throttle response to ensure the rectified issues are permanently resolved and that the vehicle operates safely. To prevent future occurrences of DTC P2126, implementing a preventive maintenance program is essential. Regular inspections of electrical connectors, especially those connecting to the APP sensor and PCM, can help identify loose or corroded connectors before they lead to substantial malfunctions. Additionally, taking measures to protect wiring from environmental damage or wear, including shielding from heat or physical abrasion, can prolong the life of these critical components. Also, conducting routine electronic systems checks ensure all voltage levels remain within specifications and prevent issues before they escalate into significant performance failures. Ultimately, a proactive maintenance approach will foster longevity in vehicle performance and reliability. In conclusion, DTC P2126 indicates a malfunction related to the APP sensor B and requires careful diagnostics to identify the underlying cause. Understanding the symptoms and possible issues associated with this DTC is essential for effective troubleshooting. Following the structured steps allowed for a systematic diagnosis, ensuring no critical component or wiring issue was overlooked. Successful resolution not only restores vehicle performance, but enhances safety. Preventive maintenance practices significantly reduce the likelihood of similar issues re-emerging, thus maintaining the good working order of vital engine management components. Engaging in these best practices solidifies one's capability to tackle and resolve automotive challenges effectively. Please like and subscribe to the channel. See you next time!